So we're starting by reviewing from yesterday. True or false? Segment SR is 1/2 of segment AK. Very good. You're getting false. Why is it false? It looks like, you know, that the diagonals bisect each other. So SR is 1/2 of AK. Oh, but they're not congruent to each other, right? Yeah, good. So the diagonals are going to be congruent in some of our other shapes, but not in a parallelogram. So since the diagonals are not congruent, the answer is false. Point S is the midpoint of AK. Okay, team, why is this one true? Why is it true? Point S is the midpoint of AK. So that is the last property on our sheet. Diagonals bisect each other. If the diagonals cut each other in half, then point S receives a promotion. It becomes a midpoint. It's the midpoint of AK, and it's also the midpoint of PR. True or false? Angle PAR is congruent to angle RKP. Good, very good. What property is that? The answer is true. What property? We always have to verify with a property. Opposite angles are congruent. Very good. Cool. Measure of angle ARP is equal to 1/2 the measure of angle ARK. So what is that statement saying? It's saying this angle is half of this angle. So we're trying to decide, did the diagonals bisect the angles? Is that a property? That's not a property. There's only 5, guys, of a parallelogram. There's only 5 properties, and diagonals bisecting the angles is not one of the properties. So nope, can't assume that, so that one is false. PR does not necessarily bisect angle ARK. If the long side of a parallelogram is 3 times the short, what is the perimeter of the parallelogram in terms of x? Y'all are awesome. Very good. So you got your parallelogram. You call one of the sides x. The longer side is triple the length. So it's 3x. Then you use your good old property, opposite sides are congruent. Opposite sides are congruent. Final answer, 8x. You're not solving for anything. Just saying the perimeter in terms of x. I'm going to make this one easier. It's not going to be drawn to scale, but I just feel like this should be easier today. So do this one. So do you spy something there? Do you spy a special right triangle inside our parallelogram? What are you doing here? You were from last unit. I thought I was done with you, right? Got our x root 3, 2x. All right, final answer, perimeter 286, using our special right triangles. Okay, here's today's lesson. We made it to the lesson. All right, so I want you to think back to when we were in the congruent triangles unit. We had 2 triangles, and we're like, ooh, are they guilty of being congruent? I don't know. And then we talked about, well, we've got to gather evidence. And if we have the right evidence, then they're guilty. If we don't have the right evidence, then we put NP, not possible. Remember? So all of our evidence was called, they would use shortcuts, right? I'm just going to put dot, dot, dot. Those were evidence that proved beyond the shadow of a doubt that those triangles were guilty of being congruent. We're going to use the same reasoning today. I'm going to give you a parallelogram, and I want you to decide beyond a shadow of a doubt. I'm not going to give you a parallelogram, sorry. I'm going to give you a quadrilateral, and you have to decide whether it's for sure a parallelogram or not. Do you have to check all the properties? Is there a shortcut like there was for triangles? How do you confirm that it's a parallelogram? So that's what we're answering today. How do I know that this is a parallelogram? And how many properties do I have to check? So, kind of, Hatham. So the great news is, I'm going to give you a checklist. I'm going to give you 5 things. If any one of those 5 things is true, just one. Any one out of those 5 things is true from this list, then it is for sure a parallelogram. Proven. And you don't have to go any further. Okay? So, I'm going to give you time to write down that list in your notes. It sounds like you're writing the properties down again, but you're not exactly writing the 5 properties down again. There's a little bit of variation. So I want you to write this checklist down, and this is your go-to for proving that a quadrilateral is a parallelogram. So go ahead and write those down. Okay, let's talk about these. This word is so important. Both pairs of opposite sides need to be parallel. If you do not see arrows on both sides, nope, you're not in the clear yet. Both pairs of opposite sides congruent, not just one. Both pairs of opposite angles would need to be congruent. Diagonals need to bisect each other. One diagonal can't just bisect the other, so tick mark, double tick mark, double tick mark. And then here's our new one. One pair of opposite sides can be both parallel and congruent at the same time. So what I mean by that is this can be parallel and congruent at the same time. You can't separate them. One pair is parallel, one pair is congruent. So you can't just do a mashup of these two. It would have to be one pair that at the same time is both parallel and congruent. So that one's the one that's kind of different from our list of properties. Let's try some. Alright, look at that first one. Based off of our checklist, is that a parallelogram? Yes or no? Getting lots of yeses. Which condition does it satisfy? Both pairs of opposite sides are congruent, right? But it doesn't look like my picture here. All of the sides are congruent. Is that okay? Yeah, you can overshoot it, right? You can be an overachiever here. You just can't be an underachiever. So yes, it is a rhombus, which is a parallelogram. But anyways, so yes, A is a parallelogram. It fit one of the conditions, so we're done. B. Is B a parallelogram? You were, no. All right, so it was key that the diagonals needed to bisect each other, right? Bisect each other, not just one of them. Okay, what about this one? Enough? Is it enough? Yes, it is. That's one of the conditions on our list. Opposite angles are congruent, both pairs. So we're in the clear there. Let's do our next one. I'll give you a little bit more time to think about this one. This one's not one that you can just conclude right away. You do need to draw the picture and add some markings to it. Good. So Hatham, you're saying that in this picture, we've got some alternate interior angles that are congruent. When alternate interior angles are congruent, that means there's some parallel lines somewhere, because they're not congruent unless there's parallel lines. Well, to find out which lines are parallel, you need to draw your Z. Oh, now I see which ones are parallel. Oh, you want to do reflexive property? Cool. Does this fit any of the things on our checklist? So you're saying the triangles are congruent. What are the triangles congruent by? Angle, side, angle. Well, angle, side, there's no angle here. We don't know that angle. Yeah, it's side, side angle. It's the bad word. Angle, side, side. So actually, we can't prove the triangle's congruent. And if you look at the markings we've got, those markings don't fit any of our conditions on the other page. Those don't fit any of the things on our checklist. So sadly, we're going to have to give up and call it a no. No, I can't prove this to be a parallelogram because I just don't have the right evidence. Okay, last one. So we've got some angles marked, and then we are told that a couple of angles are supplementary. So let's do what we did on the last problem. We've got some alternate interior angles again, making our Z. So we've got some parallel lines. Angle W and angle Z are supplementary. If you remember from last unit, if I told you that these two angles were supplementary, do you remember the vocab word for those two angles when you've got the transversals? Remember those are same side interior angles? That was a weird I. It turned into a J somehow. Well, if alternate interior angles are congruent, we have parallel lines. If same side interior angles are supplementary, those lines have to be parallel. So actually, based off of this, we can do parallel lines there. Now what's our conclusion? Ta-da! You're right. For sure, this is a parallelogram, and we can even say by definition of parallelogram. But yeah, it's the first thing on our list. Both pairs of opposite sides are parallel. Let's keep going. Is it enough information to prove parallelogram? Yes or no? So first we would mark our picture. Well, now that you mark the picture, it's easy to see. Ta-da! Yes. Opposite sides are congruent. Try that one. Okay, let's mark what evidence the jury gave us, or the lawyers. Sorry. WO is congruent to OZ. OY is congruent to XO. Remember I said we're gathering evidence to see if it's guilty of being a parallelogram. That's why I said, let's see what evidence we've gathered. Okay, what do you think? Is this a picture of diagonals bisecting each other? No, those tick marks are in the wrong spot. Yeah. So we've got two isosceles triangles there. That's kind of cool. But other than that, I'm not seeing anything to say we have enough evidence to say he's a parallelogram. Just because the triangles are similar isn't going to do much for us. Let's do a few more. O is the midpoint of WY. Okay, we're feeling really good about this one. That's a hard no, right? No. Not enough information. One diagonal can't just bisect the other. Angle W is congruent to angle Y. And angle Z and Y are supplementary. I'm just going to do this if that's okay with you. I know that if these two are supplementary, same side interior angles are supplementary, and we can do parallel lines. So what do we think here? What might help is to add some numbers into this picture, okay? So I'll make this angle 100, making this angle 80. Well, we already said Y had to equal W. Do you know how many degrees are in a quadrilateral? Oh, there's 360 degrees. So if we've used up 280 degrees, how many degrees are left? X has no choice. What? X has no choice but to be 80. Not because opposite angles are congruent, but because that's how many degrees were left. Now that I know x is 80, then it is for sure a parallelogram, right? Because opposite angles are congruent. Okay, we're almost done, promise. What about this one? So I'm going to put tick marks because a lot of you forget that those both being 22 means that they're congruent. We've got some alternate interior angles congruent. Let's draw our Z because a lot of people put arrows on the wrong sides. Oh, well with that, Z, alternate interior angles make for some parallel lines. Ooh, and then we're doing the last one on the list. One pair of opposite sides is both parallel and congruent. It's the 5th condition on the list. Yep. Yay! Okay, make sure to do your homework, try it, practice it, feel confident with it. Checking to see if the following figure is a parallelogram. Be prepared to share what your group decided on the answer. Okay, so when we are looking at a figure on a coordinate plane, we're looking for all the same things, but we get to use things like midpoint and slope and distance. The easiest thing, especially with a figure like this, is to go straight for slope. We can find the slope of the opposite sides. If the slope is the same, it means those sides are parallel. I love slope too. Okay, so what's the slope of these lines? What are the slopes? What are the slopes of those vertical segments? Yeah, very good. Undefined. So you have an undefined slope, you have an undefined slope, therefore you are parallel to you. Okay, cool. Let's find the slope of the other two lines. Rise 1, 2, run 1, 2, 3, 4, 5, 6. Rise 2, run 6, first slope of 1/3. Rise 1, 2, run 1, 2, 3, 4, 5, 6. Once again, rise 2, run 6, first slope of 1/3. Without a shadow of a doubt, is this a parallelogram? Yes. And then if you needed to explain why, opposite sides are parallel because the opposite sides had identical slopes, equal slopes. One more if you want to stay. Sometimes it's just as important to be able to describe why a figure is not a parallelogram as it is to be able to describe that it is a parallelogram. But there's nothing tricky here. It's just slope all over again. We're going to look at the slopes again. So if I look at the slope from J to K, rise 1, 2, 3, 4, 5, run 1. 1, 2, 3, 4, 5, 7. I can miscount a point. 6, 1. She didn't even make any of the opposite sides parallel at all. Okay, so we've got 4 different slopes, literally 4 different slopes. And so because the slopes were not equal, we know that it's not a parallelogram. But I like how you're pointing out other things. You could find the length. You could find the distance. You'd have to use Pythagorean theorem. But anyways, you could show that the opposite sides were not congruent. You could even go crazy and draw some diagonals in there and show that the diagonals don't bisect each other. So you do have a lot of options when you want to show your work, when you want to justify whether a figure is a parallelogram or not. Okay? You could divide it into triangles and find the angle measures. Maybe not on the coordinate plane. That's not the best place to find angles, but it is a good place to find slope and distance and midpoint, that kind of thing.